Hey guys, Mark Allen, BH Spring Solutions LLC and byHSpringSolutions.com, back again for another session of High Power University, and this is session 2 about the Girsan MC-P35. Still trying to get that model name and number and all that stuff right. We've completely detailed stripped except for one component, that be the trigger subassembly. Learn a little bit about compatibility with some of BH Spring Solutions components, the old RDIH, now BH tactical ergonomic shooting grips. These are not compatible with the new Girsan. The Girsan grip frame, and I'm specifically speaking about not so much in that area there, but on this side right here, it's got some dimensional different stuff going on with the FN Brownings as by comparison. Those don't work out. These are a pair of standard BH Spring Solutions Masters grips, just the plain version, contoured for the thumb. Reason this is a subject, we're going to be shooting this handgun quite a bit, and let me show you here. Those went on very, very nicely. Actually, I did not have to do any fitting of those, so kind of a strange combination in that the one-piece BH grips are not compatible. BH regular Masters grips are compatible. I think probably with some Girsans you may have to do some very, very minor fitting, but really, I mean, they followed the program pretty well. As you can see, we got really nice contour with the grip frame, creates a nice hold in the hand. So that is one thing. We won't be continuing forward with the original grips. They're okay. They make a shape of the grip frame my hand does not like as much as with the contour or the profile made by the BH Masters grips, and particularly you see how this center point of swell right here of the grips makes this entire thing a shape that the hand likes to make more than just an overglorified rectangle. So that's the reason we're going to go with those grips. Nothing wrong with the original grips, but we can determine one thing, a non-compatibility issue, and that will be with the tactical ergonomic shooting grips from BH Spring Solutions. And I don't think there's a real good, easy way to fit those, although I probably is possible. We just have some dimensional differences, and I'll tell you where the dimensional differences I think come in. It's primarily right here, and then particularly wrapping that RDIH grip, wrapping this part of the frame with the grip coming around to the grip screw. It just does not happen. We have done complete metal hardness testing. We are going to be getting to that here in just a few minutes. However, we're going to address something else first, and we've not really talked about this to this point, but I'm going to show it to you right now. Let's see if we can get the right angle. There we go. See the positioning of the trigger lever. This is a traditional high-power trigger subassembly with magazine disconnect installed, and you notice the positioning of the trigger lever. Trigger lever, for those of you who may not know, that is this part, this component right here. That trigger lever rises like this, sort of. When the trigger is pulled, it contacts the sear lever in the slide, and it creates the chain reaction that makes the gun go bang. The positioning of this trigger lever, though, however, as you're seeing it right now, is not appropriate. With a magazine disconnect installed, that trigger lever should be forward in the channel. It is kind of at a midway point right now, and it's not authoritatively being controlled to the forward position. In this position, with the magazine disconnect installed, with no magazine installed in the handgun, that trigger lever should be positioned fully and all the way forward. And we're going to explain to you kind of what we think is going on here, and then we're going to kind of show you what we think is going on. The balance of the trigger return spring and the magazine disconnect spring are not optimal. When they are optimal, you would have the trigger lever forward in the channel here at this point, very authoritatively, until we put a magazine in. Now watch that trigger lever move. When we put the magazine in, you just saw it. Now it's rearward in the channel. Now it can reach the sear lever. When the magazine is removed, it should go all the way to the front of the channel. It kind of did, kind of didn't, but watch what happens when I release the trigger. You see that? There is a point where this thing, you know, goes far enough back, meaning far enough back in this direction, where you pull the trigger and you're going to contact the sear lever, which would be inappropriate and not correct function. This is currently not correct positioning. I've not been able to induce a malfunction per se. However, we're kind of right on the line, and the punchline in all of this is this: when that magazine disconnect spring weakens at all and becomes any weaker than it currently is, it's no longer going to be able to overcome the influence of the trigger return spring, and that lever is not going to be far enough forward, in which case the firearm will inappropriately fire if hammer is cocked round in the chamber and no magazine in the handgun. So that's essentially kind of where this goes. Now, why this happens is because if you take some of the heat, some of the pressure, some of the dimension off of that spring in the magazine disconnect itself, it is favorable for quality of trigger pull. So that's kind of how this journey usually gets started. So what we're going to do is we're going to go ahead and we're going to take our grips on back off, and we're going to drop this trigger out. Basically, we need to accomplish correct function with the magazine disconnect equipped trigger before we continue firing the handgun. We want that to be operating correctly. We have not attempted this correction yet. We've not actually had this trigger subassembly out of this high power at this point. So we are going to go ahead and remove it now, and we're going to attempt a correction here with byBHSpringSolutions optimized trigger subassembly springs. And depending on how close or not holding to tolerances Girsan was with the dimensions of their... Now, I did just notice one thing right here. This is sort of a wide trigger pin up here at the top, and I'd actually kind of prefer a 1/8 nail set compared to the 3/32 nail punch that we're using, but it's going to be kind and gentle to us as it looks so far. That was a very friendly trigger pin. I kind of like to see that. That trigger pin is always a balancing act. I like to see them a little bit, little tighter than that, holding in there. So now, in order to get the trigger lever to release, we need to depress that magazine disconnect like that, and then we can go forward or we can go backward with it from there, and it will there we go. Okay, now we'll be able to... Now I put that tape there because when you come down and out, you're going to need to press down the magazine disconnect in order to get enough margin there to be able to go sideways out with the trigger. So we're just trying to save the finish. Now we're going to find out if we have enough margin for the tape. There we go. Got the right angle. We're going to find out real quick what we're working with. This is a good place for a 5/64 roll pin punch. The main thing I'm curious about is that spring here. Let's just go ahead. We'll keep the spring we're going to go with there together. We're going to go ahead and drop that trigger return spring as well. That one's a booger. Okay, we're almost far enough. Okay, now here's our trigger return spring, and they've exaggerated the bend a bit in the front of the spring. So again, we're just trying something here at this point, honestly, just to see how this is all going to, if it will come together with BH's springs compared to Girsan springs. If it does not, then we've got some dimensional difference kind of stuff going on between the Girsan trigger subassembly and an FN. So we went ahead and put in our 3-coil trigger return spring. Okay, we're good and smooth there. Okay, now we're going to go ahead and do our little balancing act involved with getting our magazine disconnect pin reinstalled here. You notice I kept that disconnect pressed in as we went ahead and pounded the pin in. Okay, well, we may have a little bit more pressure behind that now. So, okay, we're going to drop the trigger back in. Just taking a look at the Girsan trigger pin. See if we can get a focus on that. It looks like sort of a spiral disturbance of the steel on this end that's been designed, and it is, to be, I guess, a tightening design as the trigger pin goes in. So as you can see, it's fairly kind. It kind of gives you the idea that this is not going to necessarily be a tight pin for a long time, because I didn't even need to take and finish that with any kind of a punch from this side. It just all went in. Okay, now I'm going to show you what's the difference now. Now we have complete control of that trigger lever, just the way we ought to be having it. So it was stronger spring wire. That was the byHSpringSolutions magazine disconnect spring was made from, and it's definitely exerting more force on the magazine disconnect part. And now you see with our magazine in, we stay in this position, we take our magazine out, and we're back fully in the forward position. So yes, BHSpringSolutions trigger subassembly springs look like they're going to be a solution for that. Okay, now so that's the first corrective thing that we've undertaken in the Girsan P35. We will be recommencing testing. We're going to add on to this video a study of the metal hardness of the slide frame and components. However, before we do, we're going to go ahead be reassembling the handgun. At first, substantially the way that we received it, plus a BH barrel that just was much more accurate when we were doing our initial testing. And so we're going to be adding that hardness, a comparative study of the hardness of the components in the MC35 to this video from here. Okay guys, now we're going to move, after we've corrected the function in the trigger subassembly in the Girsan. And by the way, again, that was 3-coil trigger return spring, BH optimized magazine disconnect spring. The reason that worked is because the BH magazine disconnect spring is applying a little bit more force on the magazine disconnect device itself, and it's winning the tug of war with the trigger return spring when there's no magazine in the pistol. It is strong enough now to be the controlling spring when there's no magazine installed, and then when you put a magazine in and you take the pressure off of that magazine disconnect, that's when the trigger return spring becomes authoritative or becomes the boss and controls that trigger lever to the rearward position. So that's why that worked out the way that it did. And if yes, I did have a good hunch that was going to fix that problem. My partner Slav and I have chased that, or I should say we chased that through about 3 different spring designs years ago. And so the good thing to know is just a spring change like you just saw, and that does correct that function. Okay, we've got a high power metal hardness, a comparative study, and this is looking at components, and this is the Springfield SA35. We tested all of these components you're seeing in the Springfield. Those values are as you see them. The Girsan, we tested all the same ones, and then we made some notes out here, and we made some circles. And before I get into this and what all this means and everything, the one thing I want everyone watching this to understand is you should not come to any hard and fast conclusions over any of this metal hardness testing that we have done. And the reason being is because there is more to the equation. The quality of the steel would be one, the elemental makeup of the steel is a factor, and that has an influence into the relevancy of these numbers as well. However, we wanted to do this because if there's anything going on with metal hardness that is just a big red flag or a real taboo, we want to know about it going into the shooting that we're doing, obviously, because primarily we're talking about metal hardness that over the years is going to have an impact potentially on fracture resistance of the part or the component, and how quickly the part or component may wear, where there are metal to metal relationships. So that's the reason for doing this. The relevancy of this information probably is many years and several thousand rounds through SA35s or Girsans to be relevant, frankly. And I'll explain kind of how that plays into this. But we start here at the top, frame and slide, and this was the Springfield SA35's hardness measurements we had of both the frame and of the slide, and then for the Girsan. Now, these pluses and minuses, we have developed verifiable ranges, I guess you would say, of where we would expect the hardness rating of FN Browning components, frame, slide, barrel, and all the internal parts that we've done the hardness tests on. And in other words, ranges where we would expect FN Browning components to test as far as their hardness. And where we have circled, that is a component or a value that is really within the kind of just common range that we would expect to see that particular component with an FN Browning component, using those as kind of the baseline. So you see the Girsan's firing pin retaining plate, sear lever, sear, firing pin. These all tested with a hardness reading that would be very, very comparable to what we would expect to see testing the same parts by FN Browning. In some of our previous videos before, we have mentioned that these values for all of these internal components really indicate probably this is preheat treated machinable steel, it's called. It really kind of stops around 41, 42 Rockwell. And that's probably what Springfield did. And we're not judging it, saying that there's anything wrong with it whatsoever. I've even said that if I was in their position, I would probably do the same thing myself. It's probably okay. However, these lower values would indicate that, just by logic, that since the steel is softer, that over the years maybe you do start to notice wear sooner with these values. Now, there's always a flip side to metal hardness. The harder you make something, the more brittle and prone to fracture it tends to get. And again, this is somewhat dependent on quality of steel and the elemental makeup of the steel, as to how much that actually plays out in the real world. We did notice something here with the Girsan. We saw about 20% softer hardness readings of the frame than what we would expect to see in an FN Browning. And in the slide, we saw about 23% harder reading than what we would expect to see in the FN Browning. And we're going to come back and we're going to talk about that. Barrel was about 10% harder. The SA35s was about 10% softer. We don't know that there's much relevancy, connected to that particular subject. We will say, however, where the barrels are concerned, and we'll kind of show you a comparison. That's the Girsan's barrel. The eyebrow raise about the Girsan barrel's hardness is mainly because of its design. This is the older design, not meaning the older humped feed wrap design, the older barrel cam lug design, and this being the byBHSpringSolutions barrel and barrel cam lug area. You can see how this has all been reinforced. That's because this corner right here, as well as this area right down here, this has been a fracture problem for the high power design over the years. And so going harder with this barrel, this will be, over the years, this is going to be something that's going to be interesting to see. If you can see the mark there of the hardness test reading that was done. That's going to be interesting to see. Do these barrels experience anything going on like that because they're a little harder than what we would typically see in an FN Browning, and as well because of their design. The firing pin retaining plate, this is a fracture reputation component. And they did hit the same hardness that you would expect to see from an FN Browning firing pin retaining plate. Springfield went softer. As far as from a fracture risk, the SA35 would seem to be less fracture prone. However, it's probably going to wear faster, and it is a metal-to-metal relationship part with the hammer. Not so much when the hammer smacks it, but when the slide comes rearward and cocks the hammer. That's the firing pin retaining plate that does that. Okay, the ejector was the only part that we had a higher reading from Springfield than with the SA35. They're both softer than the Browning component. Years will tell us how that's going to work out. The extractor, this is an interesting one because the Girsan extractor went with a higher hardness value than did the SA35. Both of them are higher or lower than where we would expect to see a Browning extractor if it was tested for hardness. We see the sear lever, the outcome of that, the sear, the outcome of that. Slide stops were both softer than FN Browning made them. This is actually probably a plus. The FN Browning slide stops never had they were never prone to fracture anyway, or excessive wear. And those being a softer hardness amount, this may be a plus actually for the longevity of that part. Girsan, the hardness of their firing pin comparable to FN Browning. Springfield again went lower, and were harder for the Girsan, softer for the Springfield as far as the hammer. And so, you know, what do we do with this information? How do we interpret it? Again, there's other things that play into this, but there are some interesting clues about some things, and I'm going to show you one. You remember the frame, we're seeing 20 and 21. That's pretty soft. And we went to some effort to actually verify that as well. You can see we did, see if we can show it here. There's 2 marks from the hardness testing right there, and then we did another one down here, and then there's another one up here, and then we did the locking lug cam right there. Now, interesting, this locking lug cam was 36 Rockwell, but the frame that it's mashed into is 21. So the implication of that, I think that has a lot to do with why you take a look on this side, you don't actually see that locking lug cam. It's there, but it's very, very, very smooth. On this side, however, it's very, very, very prominent, and you see that. How you see the whole outline almost kind of makes you wonder if it's installed, you know, enough. When these are installed, then they're mashed to disturb the metal and make it tight in the frame. And that's 36 Rockwell metal being mashed into 21 Rockwell frame. And you know, I think all that works out, but I also think possibly that's contributory to why you see so much of the obviousness of it here on the left side, whereas you see we just don't see it on the right side at all. I think that's the nature of the interaction of those 2 different hardnesses and how they're working or with each other when they're being installed. Now the slide, this one is an interesting one because we would not expect to see slide hardness in the 43 Rockwell range, and I did stop for a day, and we got some input from my partner Slav and from our chief weapons modifications designer Leon Hubert about that. And the primary reason I wanted to know about that is because years ago, the high power did have a reputation for slide fractures, and particularly in the country of Israel. And of course, I mean, they do have that hotter than anybody else's 9mm ammunition. They want to shoot out of all of their military handguns, and they did. And FN wound up replacing skid loads of fractured, yes, you heard me right, skid loads of fractured high power slides. And I think they could have avoided a lot of that if they would have properly sprung those pistols to handle that ammunition, but there was no record that they ever did like up their recoil springs or anything like that. They just wanted to be able to put the ammo in and go, and they did, and they fractured them a lot and smoothed out the barrels a lot. And so there is this reputation. So, you know, my question, frankly, since I'm going to be one of the guys standing behind this slide, is do we have any concerns with the slide? And you'll see here, we did a couple of hardness tests there. It looks like we did like 3 right there. And we kept doing these because these numbers kept coming in between 38 and 43, and it just wasn't where we would expect the The spring feel was 29 to 30. That's kind of bullseye, right where we would expect. And I wanted input about this, and Leon Hubert and my partner Slav, the consensus of both of them was to not be over concerned about this. I will say this: we will not be testing with any kind of plus P ammunition from the get-go, and I'm not sure we will. And part of the reason is the hardness value of the slide. This is what was this is the component that was prone to fracture from excessive slide velocity. So if we do any of that, we're going to have maximum spring resistance installed, and we won't do anything else but that if we do any plus P shooting at all. The other thing that, because of where this, we did about 100 rounds with the springs that Girsan installed at the factory. Everything functioned fine. We did note the trigger lever not being controlled by the springs that were installed in the trigger subassembly. So the trigger subassembly springs have been changed. As we reassemble, we're going to keep the traditional operating system. We are going to install the balance of the BH springs, however, and we'll probably show that here in a video of all that going together as well with the BH springs. But the reason we're doing that is because there's one thing I'm going to be very insistent on, and that is we want to use springs where we have known slide velocity factors in high powers that we have all the testing done with. And we'll be taking a look at Girsan springs and trying to get an idea of what they were going for and how they compare to BH's springs and everything. However, we know the performance and the slide velocity control that we get with the byHSpringSolutions high power springs, and because we do know going in that we do have a slide that where the metal hardness is harder than what we normally have, we want to go in with known spring factor resistances and known slide velocity cycle rates that we know are good to go in the other high powers, and we know basically the performance that they produce. So that is one thing that we will be going forward with. However, nothing to say that anything is deficient in any way about Girsan springs. We're going to be evaluating those, as I said, going forward. So this is going to complete this section. We're getting much closer to continued firing and test firing and shooting with the Girsan MC35. For High Power University from BHSpringSolutions, I'm Mark Allen. Thanks for watching, folks.